Hi, my name is Charles Higton, and this is the application of velocity-based resistance training on load management and performance in athletes. Resistance training is often incorporated within athletes' training schedules to increase their capacity to produce force and power. It also enables the athlete's muscle fibers to withstand more stress. The increased power and force production from resistance training has been shown to increase athletic performance and remains a staple addition to most athletes' training routine. Coaches typically prescribe resistive loads based on a percentage of the athlete's maximal ability achieved through one repetition maximum testing, or 1RM. From that, coaches generally assign specific repetitions and sets. For example, this would look like 4 sets of 8 reps at 70% 1RM. This method of prescription appears to be great, however, it does not account for the individual needs of the athlete, such as fatigue and repetition endurance capabilities. Due to the high workload experienced by athletes throughout training and competition, accumulative fatigue can and will negatively affect performance levels inside and outside of the gym. This is where velocity-based training can play a key role in the strength development of athletes. The formula for velocity is expressed as a change in displacement over a change in time. The use of velocity-based training measures the displacement of a barbell over the course of the concentric phase of repetition. This gives us a velocity reading, either mean and/or peak. This information gives us an indication of intensity due to the near linear relationship velocity has with intensity, which is represented as percentage 1 repetition max. Essentially, as external load increases, bar velocity decreases. Using velocity to provide feedback to the athlete is an excellent tool to increase motivation and therefore performance outcomes. Visual and verbal styles of feedback have positively affected performance outcomes using bar velocities in all types of populations and genders, including athletes. Furthermore, Banyard et al. In 2021 found velocity-based training had greater beneficial effects on counter movement jump height, sprint ability, and a change of direction movements, compared to the traditional percentage-based training, and this was following a 6-week intervention period, thus providing the effectiveness of velocity-based training also in areas outside of the gym space. As stated before, bar velocity can be used to prescribe intensities because of the relationship velocity-based training has with the percentage of 1RM intensities. The reduction in bar velocity throughout a given set is indicative of muscular output and fatigue. Once fatigue onset occurs, bar velocity declines, thus giving the practitioner an accurate way of prescribing loads that account for any fatigue that may have been accrued by previous exercise or training. As shown by Richards and Cleaver in 2014, some individuals have a greater capacity to perform multiple repetitions at a set prescribed loading. Example, 70% 1RM, 4 sets of 10 reps. Some individuals may complete 10 repetitions with relative ease, whereas some may finish the set within a closer proximity of failure. According to Ruffalo et al. In 2023, training at intensities closer to the proximity of failure can lead to the greater subsequent fatigue. The use of velocity-based training mediates the real-time accrued fatigue by working within velocity loss bandwidths called relative velocity loss thresholds. These thresholds are generally set at 10, 20, or 30% velocity loss, depending on the desired performance outcomes. Weekly et al. In 2020 found that the relative velocity loss thresholds promote an individualized response to inset performance that allows for accrued fatigue and mitigates future fatigue. So far, we know that velocity-based training is effective in its use for the development of athletes and an asset to their resistance training. The application of velocity-based training can vary depending on the depth of use the practitioner chooses to implement to their athletes. Velocity-based training can simply be used just for the player feedback or motivation, all the way up to a complete programming overhaul, utilizing velocity-based training methods. Let's have a look at the technology. So reading the velocity of the bar requires the use of external equipment, and there are considerations that need to be made by the practitioner when choosing which device suits their needs best. The reliability and validity of this device should be at the forefront of this decision. Accessibility and ease of use of these devices should also be taken into account when deciding which device to go with. A systematic review by Weekly et al. In 2021 collected available research on commercially available velocity measuring devices used for resistance training. They found that linear transducers such as the GymAware device were superior in terms of accuracy, which involves attaching a cord to a bar connected to the GymAware device. A cheaper yet acceptably valid choice is the Flex device, which involves attaching the device to the end of the barbell, like a collar. Both technologies stated above offer real-time recordings of velocity via a smartphone or tablet and can be used interchangeably for various exercises. To accurately prescribe mean velocity intensities using velocity-based training, a load velocity profile must be created through testing procedures. Banyard et al. In 2018 proved the reliability of using load velocity profiles for the prescription of resistance training. A paper from Weekly et al. In 2021 provides the structure of creating a load velocity profile with 4 steps. Firstly, a maximal strength assessment via 1 repetition maximum is implemented to gather information on velocity recordings against the percentage of 1RM scores. Secondly, using that 1RM score, an incremental loading test is implemented by collecting velocities either by completing 3 reps at 20, 40, and 60% 1RM and 1 rep at 80 and 90% 1RM. Or they can complete their reps at an average of 45% of their 1RM and an average of 80% of their 1RM. Thirdly, the fastest velocity from each intensity is plotted on a graph against their respective loads, followed by a linear line of best fit. Finally, a table can be made to calculate the mean velocity, which can be used in place of this traditional prescription of percentages. This essentially makes the external load redundant, and in its place, velocities are then prescribed. The use of velocity-based training within programming can utilize the same periodization technique chosen by the practitioner, and there isn't much change in the method of programming periodization. Weekly et al. In 2021 provides details on 2 methods of programming with velocity-based training. The first way is to prescribe a set training velocity. So the athlete trains within a specific bandwidth such as 0.6 meters per second with a 5% buffer, with whatever load meets the given velocity. A velocity loss threshold or a set number of repetitions can be used. The second method is to prescribe a percentage of 1RM that lines up with the desired velocity taken from the load velocity profile that we created above. So if an athlete has a 1 rep max of 100 kilos and the desired percentage of 1 rep max is 70%, the practitioner would then prescribe the correct velocity bandwidth that lines up with the velocity measured at 70 kilos during testing. Once again, velocity thresholds or a set number of repetitions can be used. Both these methods are accurate and reliable for long-term programming and can be altered on a step-by-step basis by referring to the mean velocity of the previous set. There is plenty of flexibility that can be used with the prescription of velocity-based training. Sets and reps are based on the desired loading. For instance, a 10, 20, or 30% velocity loss, as mentioned earlier, can be used to determine the amount of loading that the athlete experiences in any given session. This takes away the unpredictability of traditional rigid programming, i.e. sets and reps, and replaces it with the flexibility to alter sets and reps based off the velocity loss that occurs. This allows for the individualization of the athlete in a way that will help with their fatigue during the resistance training session and does account for the differences between each player. Based on the current research available, velocity-based training appears to be a viable way to improve the way in which resistance training is prescribed for a variety of different performance outcomes. Velocity-based training challenges the traditional percentage-based prescription method, which is great for the ever-changing world of sport-related research. There is plenty of room for future research to be implemented on how velocity-based training can be applied to various different methods of resistance training and the success of performance outcomes associated with such training. The transition from traditional prescription methods to applying velocity-based training seems to be an easy one, and the research supports altering the way practitioners plan and implement resistance training prescription. Thank you.